Okay, our last lesson for this chapter is going to look at polynomial equations and what their graphs look like. And basically, to figure out the graphs, what we want to do is do long division to find our solutions, and then from there use that to help us figure out what the graph is going to look like. We could do this algebraically, so this example that's on here is solving this x to the 6th equation by factoring and so on, but it makes it pretty difficult. So what we're going to do is stick with a lot easier methods. So let's do this first one. We got x to the 4th minus 6x cubed plus 22x plus 15 equal to 0. So remember, when we're solving an equation, if it's equal to 0, what we're really looking for is the x-intercepts. And if we have x-intercepts, that's basically going to be our factors. So all we want to do in this case is factor this. So we've got x to the 4th, I'll just rewrite the equation, minus 6x cubed. Remember, when we're doing these, we want to put in the zeros. We have no x squared, so we put in 0x squared. We got plus 22x, and plus 15 is our final answer. So because that's equal to 0, that's our equation we want to work with. So we would do long division, and basically what we want to do is the exact same things we've been doing before, is try to factor this thing out. So we could try a 1. So we'd have 1 minus 6 plus 0 plus 22 plus 15. That doesn't work. We could try negative 1. So if we do a negative 1, that would give us 1 plus 6 plus 0 minus 22 plus 15. So 15 and 6 is 21. That would give us negative 21. That's 0. So that one works. So that means x minus 1 will work. So let's do long division using minus 1. So we'd have 1 minus 6, 0, 22, and 15. So we'll bring down our 1, multiply, add, multiply, add, multiply again. That would give us 15. And that's it. So we know x minus 1, or x plus 1 is one of our factors, or x minus 1 is our solution. Okay. So let's keep going. So there's our new one. So we have 15 once again. We already know 1 doesn't work. We could try negative 1 again if we want. So that would give us negative 1 plus 7 minus 7 and 15. That doesn't work. So let's try 3 in there. So another way of doing this, instead of trial and error, we can actually just plug them in and try long division. So if we put in a 3, so 1 times 3 is 3. Add those, we get negative 4. 3 times negative 4 is negative 12. Add those, that would give us negative 5. 3 times negative 5 is negative 15. So we guessed right. So 3 does work as well. So x minus 3 is a factor, or x equals 3. And we're down to a quadratic, so let's just factor this normally. So we would have x minus 5 and x plus 1. So plus 1 did work. Or sorry, negative 1 did work, and I didn't catch it the first time, but that's okay. So we've got all of our 4 factors. So in this case, we have 5, and we have negative 1 once again. So we actually have 2 values of negative 1 and 1 value of 3 and 5. So what we also want to do is, once we know the zeros, we want to look at the y-intercepts, the degrees, coefficients, all those kind of things to figure out a graph. So if we go back to our original, we have an x to the 4th graph, so we know that's going to be a W-type shaped graph, and it's positive. So we know it's going to be something like that to get 4 intercepts. But we also see that based on our answers, we have a 3 and a 5, so that's good. So let's suppose that was our 3, that's our 5, but we have 2 negative 1s. So we have a little bit of an error in our graph, because how could we get 2 negative 1s? Remember, with graphing, it's possible to get 2 of the same values if the graph only touches in one spot. So if we'd only touched in negative 1 like that, it's still a 4th degree, but now we've got 2 zeros at negative 1, so we would know it would look something like that. And that's the point. So basically with our x-intercepts, y-intercepts, we didn't look at the y-intercept. Y-intercept was plus 15, which is way up there, so we then would probably have a better sketch if it looked something along those lines. So based on our y-intercept, that'll help us sketch this out as well. Okay, so our graph should look something along those lines. So because in that case we had 2 negative 1s, what we call that is a multiplicity. So a multiplicity just means we have a repetition of zeros. So in this case, we got x minus 1 as one factor, so that means we'd have 1, 0 at positive 1. So remember, in that case, we would just cross through it. So in this one, we've got at positive 1, we're going right through. But we see that we have at positive 2, we have 2 of them. So that means at negative 2, we're going to have a multiplicity of 2, which would look something like that. And our last one at negative 4, we have 3, which basically means if we have a 3 multiplicity, it sort of does an S-curve. So what we know then is if we actually put this all together, we'd have the S-curve there, then it would make a downwards dip only once, and then it would kind of come back up, and then cross back down at our 1. So in this case, we got 1, 2, 3 for this one, 2 for that one, and 1 for that one, which would give us a degree 6, which we know from the original question. So all you have to remember is if it's a degree 1, it's going to cross straight through. A degree 2 makes sort of a quadratic type of shape on the graph. And if we have degree 3, it makes sort of an S-curve. And just put that all together to help you sketch out your graphs along with your x-intercepts and y-intercepts and so on. Okay, so let's kind of look at this one. We know it's a degree, we have 3 and 1, so we have a degree 4 in this case. Leading coefficient's negative. So we know a 4th degree then is going to be like an upside down W. So our end behaviors are going to be, like I said, down and down. Our zeros and x-intercepts, we know we've got negative 1, negative 1, negative 1. We have 3 of those. And then we're going to have 1 at positive 3. So our multiplicity, we have 3 and 1. And our y-intercept, we can't see it in this equation, but we could actually figure it out. If we go 1 times 1 times 1 would be 1, times negative 3 would be negative 3, times that negative out front should give us a positive 3. So from that, we should be able to sketch our graph. So let's do that. So we know at negative 1, we have a S-curve. At positive 3, we just have a regular y-intercept. We know it's got to be upside down, so it's going to come up, do a bit of an S-curve there, and then it's just going to cross back down. So we have our 3, we got our 1, we know our y-intercept was at 3. So we can see here our positive interval then is where the graph is positive, so that's going to be from negative 1 up to positive 3. And then our negative interval would be when x is less than negative 1, and when x is greater than positive 3. I guess we should just have less than or greater than, we wouldn't have equal to, because it can't be both. And that's it for that one. So yeah, to kind of draw a better graph, we've got a negative 1 S-curve, we've got a positive 3 regular one, and we cross through positive 3 as well. So our graph then should do something like that. Okay, so we can also draw graphs in terms of polynomial transformations. So remember, based on our transformations from our first unit, horizontal stretches and reflections, those still apply to those first, and then do your transformations left and right as well. So let's take a look at this first one. We have y equals x to the 4th. We're going to transform it this case. So we have a 3 times vertical stretch. You could have a half in the equation, so remember that's going to be 2 times horizontal. And the negative means we'd have horizontal reflection. And then we've got 1 to the left and 4 down. That would be our all of our transformations. So in this case, we can actually work with each coordinate. So if we take a coordinate, let's do these. So if we do a 3 times vertical stretch, so let's start with the 0, 0 one in the middle. So 3 times 0 would still be 0. 2 times horizontal would still be 0. Reflection is still 0, 0, so we're going to go 1 left, so that'd make it negative 1. And 4 down would be negative 4. Do the same thing with the other coordinates. So if we go 1, 1, do a 3 times vertical, and a negative 2 horizontal, so that'd make it negative 2, 3. 1 left would make it negative 1, or sorry, negative 3, and 4 down would make it negative 1. Let's do the negative 1 one next. So 3 times vertical, negative 2 horizontal, 1 left would be 1, 4 down would make it negative 1. And let's do our 16s as well. 3 times vertically would be 48. Negative 2 horizontally would be 4. 1 left would be 3. 4 down would be 44. And our last one should be pretty much the same. We'd have negative 4, 48. So one left would be negative 5 and 44. So once we have those coordinates, we can actually sketch the graph fairly accurately. So our original, let's graph our original first. Our original was 0, 0, 1, 1, negative 1, 1, and 216. So that's up really high, negative 216, and so on. So our original graph of y equals x to the fourth looks something like that. Oops, I messed up. Sorry, let's fix that. Because it's x to the fourth, it should actually look like a quadratic, which I just drew mine the wrong way. So it should be kind of a quadratic, sort of like that. But because it's fourth degree, we don't necessarily know. So the trick is when you have a second degree, it could be a fourth, or it could be a sixth, or it could be eighth, and so on. All of these look sort of the same. And similarly, a first degree, third degree, fifth degree, all of those could be the same too. Unless we have a change in direction, it's hard to tell how many humps there should be, and it's a fourth degree or so on. But anyway, let's go back to this one now. So our new coordinates are our 0, 0 went to negative 1, negative 4. So negative 1, negative 4, that's our new origin. Our other ones are at negative 3, negative 1, and 1, negative 1. And 3, 44, and negative 5, 44. So our 3 is really high, our negative 5 is really high, so we basically get our graph looking something like that. So the point is, when you're doing transformations, the same thing still applies, whether we have a quadratic, cubic, quartic function, makes no difference. Follow the same process for those. And that's it.